All right, in this video, we're going to look at the second half of the midterm review, version A. Let's jump in. Number 14. So to solve a radical equation, we first need to isolate the radical. In this case, it's a square root. And so to isolate, we're going to subtract x from both sides. And then because we have a square root, we need to square both sides. So with the index being a 2, squaring both sides is going to get rid of our square root. When you square the square root of x plus 18, you get x plus 18. When you square the binomial 2 minus x, we do need to write it twice and FOIL. So squaring a binomial, we can't just square the terms inside. We need to write it twice and FOIL. When we FOIL, 2 times 2 is 4. 2 times negative x is negative 2x. Negative x times 2 is negative 2x. And a negative x times a negative x would be a positive x squared. Let me make the right side of the equation look a little bit better. So first I'm going to write that trinomial in the order where our exponents are in decreasing order. So I want my x squared to come first here. So x squared will be first. I'm going to combine the negative 2x with the negative 2x to get a negative 4x. And then I'm going to put my constant of 4 in the back. So we've got a quadratic equation. And in order to solve, we need to get a 0 on one side. So let me go ahead. I think it's going to be easier to move the terms from the left-hand side to the right-hand side versus going the other way. I don't want a leading coefficient that's negative. So I'm going to move over the terms from the left to the right. So we've got 0 equals x squared minus 5x minus 14 over here. Now to solve this, we can either use the quadratic formula or we can see if it factors. And this one does factor. We can find two numbers that add to negative 5 and multiply to negative 14. Those two numbers would be a negative 7 and a positive 2. So that makes our factors x minus 7 and x plus 2. And then we're going to set our factors equal to 0 and solve. And our two potential solutions would be 7 and negative 2. Now I say potential solutions because we do have the possibility of extraneous solutions when we're solving radical equations where the index is even. So we need to check the 7 and the negative 2. So let's start with the 7. So let's check x equals 7. So to check x equals 7, we plug it in to the original equation, and we're going to see if we get a true statement. So we have the square root of 25 plus 7 is equal to 2. And the square root of 25 is 5. And so I'm getting that 5 plus 7 equals 2. And that is not true. 5 plus 7 is 12, and 12 does not equal 2. So 7 is an extraneous solution. It is not a good solution. Now if we check x equals negative 2, our other solution, this one is going to work. I'll just kind of show you quickly here. So in the case where I plug -2 into the equation, I get the square root of 16 plus a -2 is equal to 2. And that is okay because 4 minus 2 does equal 2. So 2 equals 2 and we're great. That's perfect. So when I go to state my answer to this equation, 7 is extraneous, so it would not get reported. And I would just say x equals -2. All right, let's take a look at the next one. So the next one says we want to solve the quadratic type equation. Clearly it's not quadratic. A quadratic equation, the largest exponent is a 2. You would have an x squared. And so we have an x to the 2/5. But it's quadratic type because we can use substitution to help us to make this look quadratic. And then we'll be able to use that to help us solve this equation. All right, so what we're going to do is we are going to let u equal x to the 1/5. Do not let u be this. That's not going to make it quadratic type. We want that to be a u squared. And so let's see how that works. So if we let u be x to the 1/5, then let's square both sides. So I'm gonna write this again, but I'm gonna square both sides. So we're gonna square this, we're gonna square this, and let's see what u squared is equal to. So we get u squared is equal to x to the 2/5, and that's perfect. That's exactly what we want. Now you may wonder, where did I get 2/5 from? Well, when we took x to the 1/5 and raised it to the second power, a power to a power, we're supposed to multiply those exponents. And when you multiply 1/5 times 2, you get 2/5. So back to our original problem, now I'm going to make those substitutions. So my first term is an x to the 2/5, but x to the 2/5 is u squared. Got it right down over here. And then I have a plus 5x to the 1/5. So plus 5u, because x to the 1/5 I define to be u. And then we have plus 6 equals 0. And that is perfect because I have now, with substitution, made it into a quadratic equation, and I know how to solve quadratic equations. This one factors. I want to look for two numbers that add to 5 and multiply to 6. Those two numbers would be 2 and 3. And so my equation becomes, in factored form, u plus 2 times the quantity u plus 3. I'm going to set each of those factors equal to 0. And I'm going to solve, and I get u equals -2 or u equals -3. Okay, now that's wonderful, but I have not solved the original equation. The original equation contained the variable x, not the variable u. So from here, we back substitute. So at the beginning, I defined u to be x to the 1/5. And so I'm going to back substitute, and I've now got x to the 1/5 equals -2, or x to the 1/5 equals -3. From here, I like to switch into radical form just because I think it's a little bit easier to see how we need to solve this equation, or these two equations. But if you know what to do from here, you don't have to do this extra step. But remember that a 1/5 power is a 5th root. So we have the two equations. We have the 5th root of x equals -2, or the 5th root of x equals -3. Once you switch into radical form if you want, then I think we can see that raising both sides to the 5th power is how we're going to solve for x. So a 5th root, I can undo a 5th root by raising both sides to the 5th power. So my two solutions are x equals negative 32. That's what we get when we take negative 2 times negative 2 times negative 2 times negative 2 times negative 2. And then negative 3 to the 5th is negative 243. So our two solutions are negative 32 and negative 243. All right, let's look at our next one, number 16. So we are supposed to solve and write our answer in interval notation. To solve this, our goal is to isolate x in the middle, and whatever we do to the middle to isolate x, we must do to all three parts, so the outside parts as well. So we've got negative 20 is less than or equal to 2x, which is less than 4. Then we're going to divide all three parts by 2, because again, we're trying to isolate x in the middle. And so we get negative 10 is less than or equal to x, which is less than 2. Now, three-part inequalities, they're always between the two numbers. I know you see two less than signs, or a less than or equal to sign and a less than sign. It does not mean that we're going to shade left of both of them. This is the same thing as x is greater than or equal to negative 10. So basically, we're looking for numbers that are greater than or equal to negative 10 and also less than 2. And so the shading is between. It is always, always, always between for these types of inequalities, three-part inequalities. Negative 10 is included, but 2 is not. So I'm going to use a bracket by negative 10, but a parenthesis by the 2. All right, let's take a look at 17. So 17 is an absolute value inequality, and we have this definition that I'm going to use. So we have, if you have the absolute value of A is less than or equal to B, that is equivalent to this right here. Assuming that B is greater than 0, by the way. Okay, so we are going to turn this absolute value inequality into a three-part inequality. All right, and then it becomes very similar to what we did for number 16. We are going to work to isolate x in the middle. So the first thing we're going to do is we're going to multiply all three parts by 4. That's going to clear our fraction there in the middle. So 4 times negative 3 is negative 12. When I multiply 4 times the middle, the 4's cancel. And so we've got just what's in the numerator there, 3 plus 2x, and then a 12 over here. All right, then we're going to subtract 3, all three parts, and we'll have then negative 15 is less than or equal to 2x, which is less than or equal to 9. And then finally, we're going to divide by 2, all 3 parts. We now have our x isolated in the middle. And so we have negative 15 over 2 is less than or equal to x, which is less than or equal to 9 over 2. So just as we talked about with number 16, 3-part inequalities, the shading is always between. We are looking for numbers that are greater than or equal to negative 15 halves and also less than or equal to 9 halves. So our interval notation will be in between the two numbers. To graph this, it would be helpful to, I think, anyway, to be helpful, to turn these into decimals. So negative 15 over 2 is a negative 7.5. So to plot that on my number line here, it would be in between negative 7 and negative 8. And then 9 over 2 as a decimal, that is 4.5. And so 4.5 would be here in between 4 and 5. And then I will shade in between. Feel free to use brackets on the number line, or you could use solid dots to show that those endpoints of that the interval are included. Okay, let's look at number 18. Before we split this into 2 inequalities, first thing we need to do is we do need to isolate our bars. So I'm going to divide both sides by 3. We do not distribute the 3. That's not a good idea. It works sometimes, but not all the time. So we definitely don't want to distribute our 3. I guess I should say it works with absolute value equations sometimes, but not all the time. So we definitely want to divide both sides by 3. Okay, then we have that if the absolute value of A is greater than B, then we can split this into A is greater than B or A is less than negative B. All right, so we are going to split this into 2x minus 5 is greater than 7 or 2x minus 5 is less than negative 7. And for these types of absolute value inequalities, we're going to get 2 intervals that are non-overlapping. So unlike the last problem where we got one interval, in between the 2 endpoints, this time we're going to get 2 non-overlapping intervals. So when we solve this, we're going to get x is greater than 6. I'm hoping we're okay with solving that 2-step inequality. And then over here, we're going to get x is less than negative 1. So x is greater than 6 would be this interval here. X is less than negative 1 would be this interval over here. And that is our solution set. To write it in interval notation, we've got our first interval is from negative infinity to negative 1. Then I'm going to use a u for union. And then my second interval is 6 to infinity. I am using parentheses here because this time our inequality symbol, we've got a greater than and a less than. And so those endpoints are not included. Okay, number 19. So 19 is a quadratic inequality. And for quadratic inequalities, we use sign charts. So we are going to make a sign chart for this one. The first thing we're going to do is we're going to factor. and looking for two numbers that add to -8 and multiply to 15. Those numbers would be a -5 and a -3. So here's how we factor our inequality. Then we're going to find where the factors are equal to 0. These are, I've heard them called the critical numbers. So whatever you want to call them, this is where the inequality is going to change sign from positive to negative or negative to positive. So our critical numbers are 5 and 3. Now I like to kind of help myself before I make my sign chart by putting these numbers on a number line. You don't have to do that. Just make sure you're careful as you're writing your intervals at the top of your sign chart. So 3 and 5 split my number line into 3 intervals. That first interval is from -infinity to 3. My second interval is from 3 to 5, and my third interval is from 5 to infinity. Those intervals are going to get written at the top of my sign chart. So we're going to leave the first column blank here for a second. That's where we're going to put in our factors. But up here at the top, I'm going to write, I've got -infinity to 3. I am going to use a bracket by the 3 because my inequality symbol is a greater than or equal to. Second interval is from 3 to 5. And my third interval is from 5 to infinity. And then over here in that first column that I left blank, I'm going to write in my factors, x minus 5 and x minus 3. And then finally here, I guess I'll go ahead and I'll write result here at the bottom, or resulting sign. That's going to be whether I'm going to have a positive sign or a negative sign there in each of the intervals. Okay, so the first interval is from -infinity to 3. So I need to pick a number in that interval. In my class, a lot of times I'll pick -100 because it is always in that first interval, unless you'd have a really weird factor like x plus 101. I don't know. So, but anyway, for our problems, -100 always is in that first interval. So when I plug -100 into the binomial x minus 5 in place of x, I get -105. And all I really care about is that I got a negative. When I plug it into x minus 3 for x, I get -103. A negative times a negative is a positive. So we're multiplying those factors together, and so I would get a positive result in that interval. Now I chose to plug in -100, but any number you plug in, as long as it lies in that interval, is going to give you a negative and a negative, which would then give you a positive, because a negative times the negative is a positive. Between 3 and 5, how about 4? 4 seems like a good number to plug in. 4, when plugged into x minus 5, would give you a negative. 4, when plugged into x minus 3, would give you a positive. A negative times a positive is a negative. And then a number bigger than 5, like maybe 6 would be a good choice. I get positive, positive, and a positive times a positive is a positive. Now, since our inequality, since we want x squared minus 8x plus 15 to be greater than or equal to 0, I am going to choose the positives. We're looking for a positive result. And so my solution set would be the union of the first interval and the third interval. Okay, number 20 is a rational inequality. And for rational inequalities, we also make sign charts. And so number 20 is going to require a sign chart. First thing I'm going to do is I'm going to factor the denominator. Two numbers that add to 5 and multiply to negative 14 are a positive 7 and a negative 2. So those become our factors. First, I'm going to find where the factors are equal to 0. That is what determines the intervals that we put at the top of our sign chart. So I've got negative 5, negative 7, and 2. And like I said, I like to make a number line just so I don't mess anything up. But if you can do this in your head, that's just fine. But I like to put my critical numbers on the number line in numerical order. So we've got negative 7, negative 5, and 2. Those numbers split our number line into 4 intervals. And so this is just going to be a bigger sign chart than what we had for number 19. But a bigger sign chart, the process is the same though, even though it's a bigger sign chart. So I'm going to leave that first column blank there. That's where I'm going to put in my factors. My intervals, first interval is negative infinity to negative 7. Second interval, negative 7 to negative 5. This time I'm using parentheses because my symbol is a greater than symbol. And so we do not have, the endpoints of these intervals are not included. Okay, so we wrote in our intervals. Over here on the left, I'm going to put in my factors, x plus 5, x plus 7, x minus 2. In the bottom row, I'll write the result, resulting sign, whatever you want to call it. Okay, so first interval, pick a number smaller than negative 7. You could pick negative 8, you could pick negative 9, you could pick negative 10, or you could pick negative 100. I don't know. I always pick negative 100 because it always is in that first interval. So negative 100 plus 5 is a negative 95. Negative 100 plus 7 is a negative 93. And negative 100 minus 2 is a negative 102. 3 negatives make a negative. If you have an odd number of negatives, it's going to be a negative result. Now I'm going to pick a number between negative 7 and negative 5. How about negative 6? Negative 6 plus 5 is negative 1. Negative 6 plus 7 is a positive 1. And negative 6 minus 2 is a negative 8. This is going to be a positive result because an even number of negatives is going to be positive. So 2 negatives make a positive. So if you have an even number of negatives, you're going to have a positive result. Now I'm going to pick a number between negative 5 and 2. How about 0? 0 plus 5 is 5. 0 plus 7 is 7. And 0 minus 2 is negative 2. This is going to give me a negative result because once again I have an odd number of negatives. Odd number of negatives, negative result. Then I'm going to pick a number bigger than 2. How about 3? And 3 is going to give me 3 positives, which is going to mean a positive resulting sign. I am going to pick the positives again, and that's because my inequality symbol is a greater than. I want this quotient here to be greater than or equal, or no, sorry, just greater than, sorry, greater than 0. And so that's why I chose the positive results. Final answer would be the union of the second interval and the fourth interval. Okay, 21, we've got another rational inequality. And so once again, we are going to need a sign chart. In order to make a sign chart, or so that our sign chart is significant, I guess, we need to get a 0 on one side of the inequality. And the way we do that is we subtract. So I'm going to subtract 5 over x minus 6 from both sides. So we're subtracting this from both sides of the equation. Inequality, I'm sorry, not equation. Then we need a common denominator. We need to bring those together, make a single fraction. And so I'm going to just kind of space it out a little bit because I'm going to show that I'm going to multiply both the numerator and denominator by something. So I'm going to space it out a little bit. So I need a common denominator. The first fraction is going to get multiplied top and bottom by x minus 6, and second one by x plus 3. All right, now that I have a common denominator, I'm going to go ahead and I am going to subtract numerators and retain my common denominator. I'll distribute here in the next step. I'm going to go ahead and subtract my numerators and retain my common denominator. And then I'll go ahead and distribute. So 4x minus 24 minus 5x minus 15. And this is all over x plus 3 times the quantity x minus 6. And then we get a negative x minus 39 over x plus 3 times the quantity x minus 6 is less than or equal to 0. So I combined my like terms. All right, this is perfect. This is the form that I want. Notice that now my inequality looks a lot like what number 20 looked like. So I've got a binomial up there in the numerator and two binomials or two factors there in the denominator. So now I am ready to do exactly what I did with number 21. So I just had to work a little bit harder to get it into the form that I need in order to make my sign chart. So I'm going to set my factors equal to 0 so that I can find my critical numbers. And so one of my critical numbers is going to be negative 39. And then I've got negative 3 and 6. Now, before I go any further, our inequality symbol is a less than or equal to inequality symbol. And typically that means brackets. But for this problem, because it's a rational inequality, we need to be careful. These two critical numbers here, these make the denominator equal to 0. And so I always try to make a big deal about this with my students. And the number, or in this case, numbers, there are two of them, that make the denominator equal to 0, they need to have parentheses by them. You cannot use brackets by them. So the only number that is going to get a bracket by it is the negative 39. So negative 39, it makes the numerator 0, and that's okay. We can have a numerator of 0. We just can't have a denominator of 0. So this can have brackets by it, but parentheses here and parentheses there. That is an issue. We see this issue with rational inequalities, or inequalities that contain fractions. All right, so we have 4 intervals. B stands for brackets, P stands for parentheses. So I got to be careful when I make my sign chart here. Okay, so my first interval is from -infinity to -39. Bracket there. Second interval is -39 to -3. I gotta use a bracket. I can use a bracket by -39, but -3 needs parentheses. -3 to 6, parentheses, 6 to infinity. And then over here on the left, I'm gonna write in my factors. And then the final row will be the resulting sign. All right, how about I pick -100? -100 when plugged into -x minus 39 is a positive because it would be a -100. So it'd just be 100 minus 39, that's positive. But then negative here and negative here, positive result. Remember, if we have an even number of negatives, we're gonna have a positive result. How about -4 here? -4 would be negative, negative, negative. 3 negatives would be a negative result. How about 0 for this? Negative, positive, negative. And I know I'm going kind of fast, but hopefully we're kind of getting the hang of this. This is our third sign chart of this video. So we've got negative, positive, positive. So that would be negative. All right, and then we are looking for the negatives this time because we want this to be less than or equal to 0, less than or equal to 0. And so we are looking for the negatives down here at the bottom. And so finally, our solution set, it looks like it's from -39 to -3, union 6 to infinity. And the only bracket that we have is by the -39. That is the critical number that came from the numerator. That one is allowed a bracket. The two critical numbers from the denominator need parentheses. All right, number 22. 22 is really just kind of plugging and chugging into some formulas that we discussed. For the midterm, or sorry, not the midterm, the midpoint formula. The midpoint formula says that the midpoint is equal to x1 plus x2 over 2, comma, y1 plus y2 over 2. I'm going to label my first point as x1, y1, the second point as x2, y2. And here we go. So -8 plus -4 divided by 2, comma, -9 plus 3 over 2. This gives us a -12 over 2 and a -6 over 2. And then obviously we'll simplify to -6, comma, -3. For the distance, let me write down our distance formula. So distance formula is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And so we're going to plug in our coordinates again. Let me scroll up so we can see them. All right, so we have -4 minus a -8. I'm going to square that. This is all under the square root. And then we'll have 3 minus -9 squared. When we're subtracting and what follows is a negative, we can do a plus, plus. So we'll go ahead and do that. So we've got the square root of 4 squared plus 12 squared, which is the square root of 16 plus 144. which is the square root of 160. Now, we do want you to simplify that if possible, and it does simplify. For 160, it's 16 times 10, and then 16 is 4 times 4. 10 is 2 times 5. So if we make a factor tree like this and we come across 2 of a kind, you can bring that number in front. So I see 2 4s, meaning I can bring a 4 in front. Now, even though 4 is not a prime number, I can stop those branches because once I see 2 of a kind, even if they aren't prime numbers, I can stop those branches and pull that number in front. The 2 and the 5 are not 2 of a kind, and so they stay under the square root. And so 2 times 5 is 10. So we're going to have 4 square root 10 as our distance. Okay, 23. So this one is also a distance formula problem, but it's a little bit tougher. So they give you the point 32, and then we want to find all points on the x-axis that are a distance of 4 from that point. So points on the x-axis can be written as x comma 0. Every point on the x-axis has a y-coordinate of 0. So we're going to write the point as x0. This is my x1, y1. This is my x2, y2. And we are going to use, again, the distance formula. Let me write it down again. So it's the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Now, unlike 22b, we do not know the second point, but we do know the distance, and we do know we're given the distance as 4. So I'm able to plug 4 in for the distance. So we've got x minus 3 quantity squared plus 0 minus 2 quantity squared. That's under our square root. So we have 4 equals the square root of x minus 3 quantity squared plus 4. And that's because 0 minus 2 is negative 2, and negative 2 squared is 4. Now to solve this square root equation, I can square both sides. And we know that squaring a square root, it undoes it, or makes it disappear. So now we have 16, because 4 squared is 16, equals x minus 3 quantity squared plus 4. Now at this step, sometimes students will expand, and they'll find what x minus 3 quantity squared is. And you can do that. There's no problem with that. But if you do that, then the quadratic formula needs to be used, and that's okay. I like to keep it in factored form like this because then I'm able to use the square root property to solve, and I feel like it is a little bit quicker. So I'm going to subtract 4 from both sides to get x minus 3 quantity squared equals 12. And then I'm going to use the square root property. And so I'm going to take the square root of both sides, but don't forget the plus or minus. Whenever we take the square root of both sides of an equation, it's plus or minus. The square root of x minus 3 quantity squared is x minus 3. So x minus 3 equals plus or minus 2 square root 3. Now where did I get that? Well, let me show you real quick. If I were going to do a factor tree for 12, 12 is 4 times 3, and 4 is 2 times 2. When I have 2 of a kind, I am able to bring that number in front. And then I'm going to add 3 to both sides. I'm going to put it in front of the plus or minus. That's, the proper way to do it so that there's no confusion about whether it's under the square root or not. So we get x is 3 plus or minus 2 square root 3. So we're not quite done yet. What we just found is the x coordinates of the points. So when we solved, we ended up getting 2 x's, which is great actually, because there are 2 points on the x-axis that are a distance of 4 from the point 3, 2. So for our final answer, we want to write, since it said find the points. So we need to pair each of these x values with a y coordinate of 0, because all points on the x-axis have a y coordinate of 0. So these are the 2 points. Okay, 24. So 24, we're given 2 points. Let's label them x1, y1, and x2, y2. And we need to find the equation of the line through those 2 points, and we want point-slope form as well as slope-intercept form. First, we're going to need to find the slope. And so our formula for slope is y2 minus y1 over x2 minus x1. So we're going to have 5 minus negative 2 over negative 3 minus negative 5. When you subtract a negative number, we can change to plus plus here. So we're going to get 7 over 2 as our slope. Point slope form is y minus y1 equals m times the quantity x minus x1. So it's going to be y minus a negative 2 equals 7/2 times the quantity x minus negative 5. Now you can actually use either point, it doesn't matter. You'll get the same slope-intercept form no matter which point you use. I went ahead and just used the first point, but either point is fine. And so we get, when we simplify that a little bit, we get y plus 2 equals 7/2 times the quantity x plus 5. So that is known as point slope form. To go into slope intercept form, we just need to solve the above equation for x. I'm sorry, for y, not for x, for y. So I am going to distribute the 7 over 2 to get 7 over 2x plus 35 over 2. Now, I'm doing that in my head. You're welcome to use your scientific calculator, but to take 7 over 2 and multiply times 5, you end up just getting 35 over 2. So that's where I got 35 over 2. And then I'm going to subtract 2 from both sides. And so our slope-intercept form is going to be y equals 7/2 x plus 31 over 2. And again, I'm doing that in my head, but feel free to use your scientific calculator. You don't have to do that in your head. I am just, when I take 35 over 2 and subtract 2 over 1, a common denominator is needed. So I multiplied top and bottom by 2. And so 35 over 2 minus 4 over 2. Now that we have that common denominator, we subtract numerators and retain our common denominator. So that's where I got 31 over 2. All right, we've got just 2 left. Okay, so we're supposed to, in number 25, state the domain. So for part A, we have 2 restrictions. One is that x plus 3 needs to be greater than or equal to 0. That's because the square root of a negative number is an imaginary number. So we want only real number outputs. The other restriction that we're going to have is that the denominator cannot equal 0 because division by 0 is undefined. So for both A and B, we're going to write out that the radicand has to be greater than or equal to 0, and the denominator cannot be equal to 0. When I go to factor the denominator, I'm looking for two numbers that add to -9 and multiply to 18. Those numbers would be -6 and -3. Okay, so my restrictions are that x needs to be greater than or equal to -3, and also that x cannot equal 6 or 3. So here's what I like to do. I like to shade my inequality. Okay, so here's my first restriction. X must be greater than or equal to -3. But I have another restriction, or two other restrictions. X cannot be 3 and x cannot be 6. So I need to remove those from that interval. So they need to be removed. So the shading in purple is my domain, but you just have to remember to remove the numbers 3 and 6 from that interval because they would result in division by 0, and division by 0 is undefined. So the way that we remove them is we use parentheses by those numbers. So this right here that I just put a box around is all real numbers greater than or equal to -3, with the exception of 3 and 6. We're removing 3 and 6. And we do that by using parentheses. All right, let's see part B. Part B is very similar. We're going to set the radicand greater than or equal to 0. And we're going to also say that the denominator cannot equal 0. So we get x is greater than or equal to -1. Two numbers that add to -8 and multiply to -20 are -10 and 2. And so we do not want x to be 10, and we do not want x to be -2. All right, so here's -1, and we want x to be greater than or equal to -1. That is our first restriction on the domain. Then -2 and 10, they need to be removed, but -2 is not in that interval. So I do need to remove 10 from the interval because when x is 10, our denominator is 0, and division by 0 is undefined. But the -2 can get ignored. It's not in that interval. And so by restricting x and requiring x to be greater than or equal to -1, then x will not be -2. That's not an issue. It's outside the interval. So this time my domain would be -1 to 10, 10 to infinity. So 10 was removed from that interval because 10 falls in that interval, but the -2 can be ignored because it is not in that interval. And so by requiring x to be greater than or equal to -1, x will not be -2. All right, we've made it to the end. Number 26. So we need to find and simplify the difference quotient. Before I before I start that fraction there, that quotient, I want to find this first. So I'm going to find this part first before I put it into that fraction there, because otherwise it gets pretty crazy. So f of x plus h is, we're going to take x plus h and we're going to plug it into the equation in place of x. It is not, I'm going to erase this in just a second, it does not equal f of x plus f of h. You can't distribute an f. That's not function notation. That's not how it works. Okay, so do not do that. We just take the equation, 3x squared plus 6x, and in place of the x, we're going to substitute in an x plus h. All right, now, when you square x plus h, you can't just square the x and square the h. We need to write it twice and FOIL. So I am going to distribute the 3 in just a minute. First, I'm going to square the x plus h. X times x is x squared. X times h is xh. And then you're going to have another xh. And then h times h is h squared. So I went ahead and I combined those middle terms there. So you're going to have an xh, and then you're going to have a second xh. So xh plus xh is a 2xh. So this is what we get when we square x plus h. Now I'm going to go ahead and I'll distribute the 3. And I'll distribute my 6 as well. That 6 can be distributed whenever. I just went ahead and waited, I guess, to distribute it until I distributed the 3. Okay, so now I'm going to go ahead and start this difference quotient. So in the numerator, I first have f of x plus h. And f of x plus h is what we just found. So I'm going to copy that up in the numerator over on the left. By the way, there are no like terms. So I wasn't able, if I could combine like terms, I would have, but these are all unlike terms. Okay, also up in the numerator, I'm supposed to subtract f of x. F of x is just our original function that was in the problem. And so I'm going to subtract f of x. Now I'm going to highlight something because this is often missed by students. So my f of x is 3x squared plus 6x. However, when I subtract f of x in the numerator, I don't want to just subtract the 3x squared. I also need to subtract the 6x. So all terms of f of x are going to change sign when you subtract f of x in the numerator. And then the whole thing, whoops, I'm still in the highlighter. Whole thing is over h. Now I do have quite a bit that I can get rid of in the numerator. I've got a 3x squared, a negative 3x squared, a positive 6x, and a negative 6x. So I'm left with 6xh plus 3h squared plus 6h all over h. And then I can reduce. I can factor an h out of the numerator. All terms of the numerator contain an h. So I can take out an h, and then I can cancel that h with the h in the denominator. So final answer for this one, 6x plus 3h plus 6. All right, well, everybody, thank you so much for watching. Good luck on your exam, and yeah, good luck.